Hello students, in this video we will discuss some results based on Mobius function. So we know it is denoted by mu of n, and here we see some applications. So here we have to prove this is the prime factorization of n, and given small f is multiplicative function that is not identically 0, prove this. Summation d divides n, mu d fd is equal to 1 minus fp1, 1 minus fp2 and 1 minus fpr. So this type of result we have to prove here. Now for this we use a result, that is, let denote left hand side by capital F of n. D divides n, mu d f of d. And by a previous formula, as small f is multiplicative, which imply capital F is multiplicative. That capital F is also multiplicative. So once we have this formula, we can easily prove this. For that, first we prove this formula for n is equal to p power k. Let f of p power k is, that is, d divides p power k mu d f of d. So let us expand this summation. So for the divisors of p power k, again we know divisors of p power k are 1 to p power k. Let us put the values. First value is 1, second value is p, third value is p square, and last value is p power k. So as we are well aware of the definition of mu, when p square divides n, then the value of Mobius function is 0. That means p square onwards all the terms become 0. So we are left with mu1 is 1, f1 is 1, this is 1 plus, and mu p is minus 1 power 1 fp, that is 1 minus fp. So here, because f is not identically 0, so by that f1 is 1. Now as f is multiplicative, f of n becomes f of p1 power k1, p2 power k2, pr power kr, which using multiplicity, f of p1 power k1, f of p2 power k2, f of pr power kr. So putting the values, this may be written as 1 minus fp1, 1 minus fp2, 1 minus fpr actually. So which is the desired right hand side. Hence the result. There are few applications of this result also. One of them is we have to prove summation d divides n, mu d tau of d is equal to minus 1 power r. As you see, this is the application of this. We have chosen some value of this small f. Here it is denoted by tau. So just what we have to do, we have to put the values on the right hand side. So let us start with the left hand side, that is d divides n, mu d tau of d. So as you see, this tau also satisfy, tau is multiplicative, not identically 0. So we can put it on the right hand side. It is 1 minus tau p1, 1 minus tau p2, 1 minus tau pr. And how much is this? Tau p1. So it gives number of positive divisors. And how many positive divisors for a prime? 2, 1 and itself. The value is 1 minus 2, 1 minus 2, 1 minus 2. That is minus 1, minus 1, minus 1. And how many times this minus will appear? R times. So its value is minus 1 power r, which is the desired answer. Another application of this formula that is of this form. So we need to prove this. So here again, when we compare left hand sides, very easily we can see that this FD is 1 by D. So just what we have to do is we have to replace these values on the right hand side. And one more thing we need to say, we need to check whether this 1 by D is multiplicative and not identically 0. And very easily we can cross verify 1 by D is a multiplicative function because 1 by D1 D2 is equal to 1 by D1 into 1 by D2. And also this is identically non-zero. So let us use that result here. Mu D by D is equal to 1 minus, so here you see what we get from the prime factorization. If n is p1 power k1, p2 power k2, pr power kr. And what is the value of fp1? That is 1 by p1. What is the value of fp2? 1 minus 1 by p2. And similarly 1 minus 1 by pr, which is the desired right hand side. Okay, another numerical. So here Sn denotes number of scare-free divisors. What are scare-free divisors? Which are not divisible by scare of any number. And next, establish that this is equal to this is equal to this, and where Wn is number of distinct prime divisors, as we already discussed in previous numerical. Okay, let us start with the prime factorization of n, that is p1 power k1, p2 power k2, pr power kr. Now let us choose any scare-free divisor. Any scare-free divisor of n is of the form p1 power alpha 1, p2 power alpha 2, pr power alpha r. Now for scare-free, what are the possibilities for alpha I? Only two possibilities, 0 and 1. For I from 1 to r, there are only two possibilities. Then total number of scare-free divisors. So which is given by, here it is the Sn denote the number of scare-free divisors. It is denoted by Sn, and very easily we can calculate them here. How many possibilities here? 1 plus 1, 1 plus 1. So we can put all these values here. 1 plus 1, 1 plus 1, so on. 1 plus 1. So how many times? R times. So which is 2 power r. And as we are given Wn denote the distinct prime divisors. And how many distinct prime divisors are there? R again. So which further is equal to 2 power Wn. So as you see, we have already proved here Sn is equal to 2 power Wn. So one part of the result is proved. Okay, next we prove that this summation mod of mu d is equal to 2 power Wn. Now to prove this, we have to rewrite the definition of this Mobius function, because here we are using mod of this. So that by definition mu of n becomes 1, 0, 1. When it is 1, if n is equal to 1. When it is 0, when some prime scale divides n. And when it is again 1, when it is p1, p2, pr. You know, as per previous definition, then third value is when the number of distinct primes are r, we have to take here minus 1 power r. But because of mod, the only possible value is plus 1. Okay, next let Fn is equal to mod of mu n, and we prove this is a multiplicative function. For that, we choose two relatively prime integers. Now, as per definition we have written here, if either of them is 1, either m is 1 or n is 1, very clearly Fmn is equal to Fm Fn. And second step, if either of them is divisible by p square or p square divides n, then again Fmn is equal to 0, which is Fm Fn. And at third step, let m and n are square free, then m is equal to p1 p2 pr and n is equal to q1 q2 qs. Then again by definition f mn is equal to 1, which is fm fn, because here when you multiply, what is the value? 1. And what is value of fm? 1. What is value of fn? 1 is equal to 1 into 1. So by this function is a multiplicative function. So then write Fn is equal to summation d divides n mu of d. So as we already proved, this is multiplicative function. So this implies this Fn is multiplicative. This is multiplicative. Now for prime factorization of n, we can easily write f of n is equal to f of p1 power k1, p2 power k2, pr power kr. And we can easily write f of pi power ki is equal to summation d divides pi power ki mu of d. The putting value here. So when we expand this summation, as you know, we have how many divisors? Ki plus 1. So opening all these, mu of 1, mu of pi, mu of pi square, and last is mu of pi power ki. So from the definition, its value is 1, 1, and as you know that after p square, all of these become 0. The only possible solution is 2. So putting this solution here, let me write it here. Let me write it here. So putting this value here, so Fn becomes 2 into 2 into 2 into 2. How many times? R times. So that is 2 power R. So once again, which is equal to 2 power Wn. Then combining all the results, we get that Sn is equal to d divides n mu of d mod 2 power omega n. Hence the result.